When I'm factoring out the greatest common factor, or GCF, of a polynomial, what I'm looking for is the number and or variables that all the terms in the expression can be divided by. It's basically like reverse distributive property. I want to see what I can divide out of all the terms instead of what I would multiply into all the terms using distributive property. So let's take a look at a couple examples. First up, I've got 6x plus 10y. Now what I'm looking for is the biggest number that both 6 and 10 can be divided by. And the biggest number they both have in common is going to be a 2. There's no variables they have in common. One term as an x, one term as a y. So 2 is my greatest common factor. What I'm going to do though to factor this is after the 2 put a set of parentheses down, and what I'm going to do is put sort of what's left over after I've factored out or divided out a 2 from both terms. So dividing 6x by 2 gets me a 3x. Then I have a plus sign. Dividing 10y by 2 gets me a 5y, and that's going to be my factored expression. Now what I meant by reverse distributive property, this is the way you check your answer too, is if I were to redistribute the 2 into the parentheses, 2 times 3x gets us a 6y, and 2 times 5y gets us a 10y. So I end up with the same expression. So that's what it means to factor using the greatest common factor. I'll show you a couple more examples and explain them if you want to actually pause the video and try them for yourself. These ones are pretty easy to do, and factoring is one of those skills that you got to practice it. So I would pause the video and try these 3 on your own, but if you just want to kind of watch and refresh, I'll go ahead and just work them out as well. So next up, we've got 12 minus 42m. So again, I want to look for the biggest number that both terms have in common. And I may be tempted to go with something like a 2, for example. 2 could be divided into both of those expressions just fine. The thing is, 2 is not the greatest common factor. Remember, the G in greatest common factor means we need the biggest number both terms are divided by. So if you're not good with division, then use a calculator, use some guess and check. But the biggest number that both terms are divisible by is a 6. And once again, there's no variable greatest common factor since one term does not have a variable at all. So after the 6, I'm going to put a set of parentheses down and say what's left over once I've divided out a 6. So 12 divided by 6 gets me a 2. Then I have a minus sign. 42 divided by 6 gets me a 7, and there's still the m that we did not take out. So there's my factored answer. If I wanted to check it, I could redistribute the 6 in and see that I end up back where I started. And I'm just going to keep going through unless you've paused it and trying these for yourself. I'll just keep going. 4x to the 4th plus 24x squared. The biggest number that both terms have in common is a 4. Once again, don't be tempted to take a 2 out. It's true that you could divide both 4 and 24 by 2, but that's not the greatest number you could take out, so you will not have factored completely. This time there is a variable that I have in common, and it's actually x squared. If you have trouble seeing why it's x squared, think of it this way. X to the 4th means x, 4 x's. X squared means x times x. So what I want to do is take out what both of them have in common. The most that both of them have is an x to the 2nd power. So I'm going to take out that x squared from both terms. I can't take out more because this didn't have any more x's to take out. So once again, let's go through and divide our terms by our greatest common factor. And in parentheses, I'll put my leftovers. So 4x to the 4th divided by 4x squared leaves me with 1, which I guess I don't need there. And then there's an x squared left over. If I were to remultiply that, I could see that I end up back where I started. A plus sign comes next. 24 divided by 4 gets me a 6. And there's no variables left over because I had x squared and I took out x squared. So there's my factored answer using the greatest common factor method. And last up, one note about this. Anytime you have a negative sign as your first term, you're going to want to factor out a negative number. Even if it's a -1, or when we factor, we never really want to have a negative as our first term. So in this case, I can see that 2 is the greatest common factor from both 2 and 8. It's the biggest number they're both divisible by. But I'm going to take a -2 out because I always want that first term to be positive. So if you ever see a negative in front, make sure a negative is part of the greatest common factor. Next up is my variables, and like we discussed last time in the last example, the most variables both have in common is m squared. So I'm going to take that out of both of them. If you have trouble seeing it, write it out. That's got 2 m's. I can take 2 m's out of there with an m left over from the 2nd term. So in parentheses then, be careful here. I had -2m squared and I took out -2m squared. And some people are tempted to just leave that space blank or put a 0 down, but that's not the case. Remember, we're dividing when we take out. So if you divide something by itself, what's left behind is just a +1. And if you wanted to check that, if you redistribute, -2m squared times 1 is negative 2m squared. So don't leave that space blank. Don't put a 0 in that space. Put a 1. Next up, I don't have a plus sign. I have a minus sign this time. Positive 8 divided by negative 2 gets you a negative 4. My signs have changed this time. And then I had 1m left over. So there is going to be my factored expression. Notice again that negative sign I took out, which changed all the signs within the parentheses.